Here we will explore the length in different coordinate system. When we talk about length, we should talk about tool to measure the distance between 2 points. Not only distance, volume, surface, area, anything. But in more simple, we will talk now just about d equal, the dimension of the space is equal to be able to visualize the idea. And of course, the generalization is natural then. If I take 1 point and make infinitesimal displacement, I start from xy and make this very small displacement. I arrive to x plus dx and y plus dy. And then I ask you find the distance between these 2 points. Most of us will just directly say the distance is dx square plus dy square. Okay, it's right, but it's not generally right. It's right if there is Cartesian coordinate system. If I can describe this object by Cartesian coordinate system, but this is not generally true for any space. So generally, if I could take a Cartesian coordinate system where there is the axes are parallel and rectangular and everything is simple and elegant, then okay, this metric is right to measure the distance between 2 points. But there is no reason, and sometimes it's not possible to choose such coordinate system. And other might choose another coordinate system, like in figure B, where it is the axes are not parallel and they are curved, not straight and not rectangular. And this is general case of coordinate system. In such cases, we need the metric is defined in another way. We need to introduce some coefficient in front of any quadratic term. Then the s square will be equal to g11 dx square plus 2g12 dx dy plus g22 dy square. This coefficient g11, g12, g22 express physically how the coordinate system themselves change when I jump from one point to another point. If we could find such coordinate system, Cartesian coordinate system, then this coefficient will be equal just to Kronecker delta Ig. That means Gig is equal to delta Ig. If the two indices are the same, then they are equal 1. If the indices are different, then this coefficient will be 0. And here, naturally, we will recover back the case of the familiar metric where we just in Cartesian coordinate, when we just measure the distance between 2 points by dx square plus dy square. If that is true, then the geometry of the space is called flat. But if not, it's called a curve. So being flat or not for any space is completely depends on the existence, on possible existence of such coordinate system. And even if it is possible to choose other complicated one, that means, okay, at least it is possible. But of course, it will be possible to make the life more complicated. But I am talking now about the possibility of choosing to describe this object or this space. Here we will explore finally some example of flat and curve. The surface of cylinder is curved, as is flat, because it could be described as coordinate. I could find the Cartesian coordinate to describe it. Also, for the coin except the top, it could be flat. And saddle of horse, it could be flat because it could be described in Cartesian coordinate. And I can choose metric like that, simple metric, whereas Gig is just equal delta Ig. Other example of curve is surface or surface of the sphere. The surface of the sphere, maybe most of us will think it is flat, but it is not flat because in best cases, when I choose theta and phi as coordinate system, then the metric will be r will be arise in the metric. So it is not flat in general. And other example of non-flat, for example, we can take the coin with including the top point. And we will explore later on this metric in more general case, where this metric is just could be described as a covariant tensor in more general case.